The block model approach employs the concrete representation abstract method of solving word problems. The block model approach helps people visualize situations because it creates concrete picture from abstract situation. It may satisfy the pupils' learning through seeing and doing. Finally, it transforms words into recognizable picture for young minds. Features of the model method. 1. A diagram is required to represent the word problem. 2. These diagrams clarifies the problem and interprets the problem correctly. 3. This method is introduced early to children in the lower primary to the upper primary. With the block model approach, it gives us some information on the following. 1. Information on the number of units that represents one of the objects that is being compared. 2. We are also able to tell the number of units that represent the other objects that is being compared. 3. The difference between the number of units between two objects. 4. We can tell the total number of units of everything we have. Let's look at the various forms of bar or block model approach. 1. The comparison model. This is a type of bar model where we draw bars side by side so that we can see the difference between the objects separately. The comparison model is a visual representation used to help students understand and solve word problems involving comparison, particularly those that require comparing quantities to determine the difference, more or fewer. This model is often represented with bar diagrams, also known as tape diagrams, and helps students visualize the relationship between the quantities being compared. Let's take a look at the components of the comparison model. Bars or strips. The bars or strips represents the quantity being compared. Difference. The difference tells us the amount by which one quantity is more or less than the other. Let's look at the structure of the comparison model approach. The model typically consists of two bars of different lengths, placed either side by side or one on top of the other. One bar represents the larger quantity. The other bar represents the smaller quantity. The difference is represented by the length that extends beyond the smaller bar if placed side by side, or the gap between them if placed one on top of the other. How to use the model. 1. Identify the quantities. Read the word problem carefully to determine the quantities being compared and identify which is larger and which is smaller. 2. Draw the bars. Create two bars proportional to the quantities being compared. 3. Mark the difference. Indicate the difference between the quantities either by the extended length of the larger bar or the gap between the bars. 4. Solve for the unknown. Use the visual representation to set up an equation and solve for the unknown value. Let's look at this example. Jacob had twice as many marbles as Jerry. Kenny had 3 times as many marbles as Jacob. They had 846 marbles altogether. How many more marbles did Kenny have than Jerry? So from our question, we will start with our Jerry. So we could see that Jerry has 1 block. Jacob is going to have 2 blocks because Jacob have twice as many as Jerry. So we have 2 blocks for Jacob. And Kenny we'll definitely have, that's right, 6 blocks, because it has 3 times as many as Jacob. So we have 6 blocks for Kenny. So I get complaints from students that drawing the block is tedious and it doesn't make them efficient. So in order to cater for that problem, we will do away with the block drawing of the rectangles, since it takes a lot of time in class. So we are going to stick with the number line approach, but with the same thing. So if you are drawing one block as 1 unit, we'll have a number line as 1 unit. So I'll be cleaning the block. Okay, so with the number line, we know Jerry has 1 unit. So we'll have just a unit for Jerry. Unit for Jerry, so we have 1 line for Jerry. Jacob had twice as many as Jerry, so we have 2 units for Jacob because he had twice as many as Jerry. Kenny had 3 times as many as Jacob, so we are going to have so we have 6 units for Kenny. 6 units for Kenny. 6 units for Kenny. We have 1, 2, 3, 4, 5, and 6. The question mentioned of that they all have a total of 846. So they all have a total. So they have a total of 846 marbles. 846 marbles. That's the number of marbles Jerry have, plus the number of marbles Jacob have, plus the number of marbles Kenny have. 846. So looking at this, we can see that we have a total units of 9. We have 9 units. That's a total units of 9. Total units of 9. So that's 1, 2, 3. You can see up to 9. So from here we can conclude that 9 units is equivalent to 846. So if 9 units is equivalent to 846, then 1 unit will be 846 divided by 9, giving us 94 marbles. Is our question answered? No. The questions want us to look for how many more marbles that Kenny have than Jerry. How many more marbles that Kenny have than Jerry? Most students would like to solve this as find the number of marbles Jerry have, that's the 94, and find the number of marbles that Kenny have and find the difference. But we could do this in a more efficient way by visualizing using the diagram we have here. We could see from the diagram that Kenny have how many units than Jerry? Yeah, you're right. Kenny have 5 more units. You could see from the diagram that Kenny have 5 more units than Jerry. Kenny have 5 more units than Jerry. That's what we are looking for. That section, that part, 5 more units than Jerry. And we know that a unit is equivalent to 94 marbles. If that's the case, then Kenny will have 5 times 94 more marbles than Jerry. So we have 5 times 94, giving us 470 marbles. 470 marbles. So at the end, we write our answer clearly that Kenny have 470 marbles, 470 more marbles than Jerry. Kenny have 470 more marbles than Jerry. Yeah, so that's how the comparison model works. Good. Let's look at the second approach, before and after model. This type of problems usually has some quantities at the start, and at the end something happens, and then there is different set of quantities. The questions usually ask us to find something either at the start or at the end of the situation or problem. The before and after model is a visual strategy used to solve word problems that involve change over time or event, such as increase, decreases, gains, or losses. This model helps students understand how quantities change from an initial state to a final state. By illustrating the changes clearly, component of the before and after model. Before, the initial quantity or state. Change, the amount by which the initial quantity increases or decreases. After, the final quantity or state after the change. Structure of the model. The model typically consists of two parts. 1. A before bar, representing the initial quantity. 2. An after bar, representing the final quantity after the change. The change is often represented by an addition or subtraction to the initial bar. How to use the model. 1. Identify the initial quantity, change, and final quantity. Read the word problem carefully to determine what the initial quantity is, how it changes, and what the final quantity becomes. 2. Draw the bars. Create two bars, one for the initial quantity, that's the before, and one for the final quantity, that's the after, showing the change between them. 5. Illustrate the change. Indicate the increase or decrease as an addition segment or a removal segment on the bar. 6. Solve for the unknown. Use the visual representation to set up an equation and solve for the unknown value. Let's look at an example. In a choir, the ratio of the number of boys to the number of girls is 3:1. In the following month, 40 new members joined the choir, and as a result, there were 3 times as many girls and twice as many boys as before. How many members were there in the choir at first? Okay, so let's take a look at the before-after problem, or the before-after model. Now we have a question here. It says that in a choir, the ratio of the number of boys to the number of girls was 3:1. In the following month, 40 new members joined the choir, and as a result, there were 3 times as many girls and twice as many boys as before. How many members were there in the choir at first? So looking at the question like this question is a kind of before-after model. How do we know? Because in the question, it gives you a certain condition that was before, and the next thing you see, something happens, then the whole total changes, or something changes at the end. That is the before-after model. So at the start, there's a certain condition, then within the line, something happens, then values or quantities change from the problem. So looking at this question, they said in a quad, the ratio of the number of boys to girls is 3:1. So this means that if girl has 1 unit, then boys will have 3 units. So let's take a look at our before condition. So we have before boys. Girls. So girls have 1 unit, then boys should have 3 units. Because the question says that the ratio of the number of boys to girls is 3:1. Notice that in the question here, we were not giving the total number of boys and girls. We don't know. So let's put question mark. We don't know that yet. In the following month, something happened. 40 new members joined the quad. So that is our after condition. After. When 40 joined, let's see what happened to boys. We had twice as many boys and 3 times as many girls. So boys, we have 3 times. So our boys in the before have 3 units. So our boys after became twice. So that will be 6 units. Six, good. And the girls, we had 3 times of the girls. 3 times of the girls. So that became 3 units. So we have 1, 2, 3 units. And remember that this happened when 40 joined. So our total, if you still don't know, question mark plus 40. Good. Plus 40. This will happen. Let's take a look at the before condition. The number of boys were 3. The ratio of the number of boys to girls was 3:1. After 40 joined, the boys, we had twice as many as boys as before, and 3 times as many girls as before. And we know the total number of boys and girls in the before condition. We don't know that was question mark, but remember, 4 units made up that total. 4 units in the before made up that total. So we could see that in the after condition, the 4 units over there is actually the total that was before. The total that was before. The total that was before. So the 4 units, that is 1, 2, 3, 4, made up the total. So let's see whether we can fish out that before. So we have 1, 2, 3, 4. So this 4 unit makes up the total in the before. So let's see the change. What happened to the boys? You realize that we had 3 more joining the boys after 40 joined, and the girls 2 more joined. So from this, we can conclude that the 3 units left in the boys plus the 2 units left out with the girls is equivalent to the 40, because this change happened when 40 was added to the members which we don't know. So if that's the case, you can say that this unit 2, 3, 4, 5 units, these units so we could say that 5 units is equivalent to 40. Then 1 unit will be equivalent to 40 divided by 5, giving us 8. So it means that each unit is 8. But what are we asked to find? The question says, how many members were there in the choir at first? How many members were there in the choir at first? So before, we have 4 units. So we know that each unit is 8. Then that will be 4 times 8. That will give you 32 members. So there were 32 members at first. The third approach, part-whole models. A part-whole models is a visual tool used to help students understand and solve word problems, especially those involving addition and subtraction. It breaks down a whole into its constituent parts, making it easier to see the relationship between the numbers involved. Here is how it works and how it can be applied. Components of part-whole model. Whole, the total amount or sum. Parts, the individual quantities that combines to form the whole. Let's look at the structure of the part-whole model. The model typically consists of a diagram with 3 sections. 1. A larger section representing the whole. 2. 2 smaller sections or bars representing the parts. How to use the model. Identify the whole and the parts. Read the word problems carefully and determine which number represents the whole and which number represents the parts. Draw the model. Create a diagram with 1 large section labeled whole and 2 smaller sections labeled part 1 and part 2. Fill in the known values. Enter the known values from the word problems into the appropriate sections. And the last point, solve for the unknown. Use the relationship between the parts and the whole to find the unknown value. This might involve addition to find the whole or subtraction to find a missing part. Let's take a look at this problem. There were 130 marbles in a box. 80 of them were red and the rest were green and yellow. If there were twice as many red marbles as green marbles, how many yellow marbles were there? Let's take a look at the part-whole model. The part-whole model. Now, our question here says that there were 130 marbles in a box. 80 of them were red and the rest were green and yellow. The rest were green and yellow. If there were twice as many red marbles as green marbles, how many yellow marbles were there? So with the part-whole model, your first step is to be able to identify your whole. Be able to identify your whole. So we know that with this, our whole is 130 marbles. Our whole is 130 marbles. So we can draw model (130 marbles), and we have 80 red. So out of the 130, 80 is made up of red, 80 is made up of red, okay, 80 is made up of red. Good. And the rest were green and yellow. The rest were green and yellow. The rest were green and yellow. So that means this portion was made up of green and yellow. 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 Good. We're given information that if there were twice as many red marbles as green marbles, if there were twice as many red marbles as green, we know that our green marbles is a reference. So if green is 1, then red is 2. But now we know our number of red marbles to be 80. So if you know that the number of red marbles in the 130 marbles is 80, then the number of green marbles should be 40, because I said if there were twice as many red marbles as green marbles. So meaning that 2 times the number of green marbles should give us the red marbles. So from here, we could say that the green is 80 divided by 2 minus 40. So this part 40. Then the rest is yellow. So from here is yellow, which we don't know. But we know that the whole part is 130. The whole part is 130. The whole part is 130. And if that's the case, then yellow could be defined as what? 130 minus 80 plus 40. Because since this part is equivalent, so from here to 80, 40, then we don't know this part. So it's just by subtracting 120 from 30, then you have this. This part represents our yellow. So it becomes 130 minus 80 plus 40, 120. So we have 10 marbles. It means the number of yellow marbles that were there was 10 marbles. So there were 10 yellow marbles.